Good evening, everyone. My name is Aftab. I'm a faculty member at IIIT Hyderabad in India. And this is actually a very interesting project because it started out as a discussion with one of my friends who actually works or runs an elderly care center in India. And we're having this issue with, I guess, all around the world. With the elderly population being more than young people. So we have these elderly care centers that are run, and they're typically, like 70, 80, 100 rooms. And we have some nursing staff that is basically taking care of these people. Now, the one of the major problems is that we want to make sure that we want to use technology, and we want to make sure that the number of people, nursing staff that is required is as low as possible, and that A reduces the cost as well and reduces dependency as well. So, and also increases, we can do some data analysis and make sure that everybody is happy and healthy. One of the key problems that she pointed out is that at particularly with night shifts and all, uh, making sure that people are happy and healthy at night is actually a bigger problem than otherwise during the daytimes. So one of the issues that they faced is there was there are people falling off the bed, and there's basically no way of sort of for them to either call for help or for somebody to come and help them. It sometimes it goes all the way up to the morning that they're discovered, and they can sustain severe injuries and so on. And in our discussions, we wanted to make sure whether we can find a solution where we can, as soon as this kind of an event happens, we can sort of trigger an alarm and know that this has happened. So we started looking at technologies, and I work on pressure sensors. So I thought we can probably look into this. Of course, as any scientist would do, I started looking at what are the existing solutions. It turns out people have actually made some of these things, like you can have IR camera-based solutions and normal camera-based solutions and IR camera-based solutions that can be put inside and we so I can sort of monitor these patients and make sure that they're okay during the night. And of course, there are some variables, wearable bands are there, rings are there, where if it's worn and somebody's having this kind of a fall incident, they will be able to trigger an alarm. The problem with these is, of course, the first two you can probably guess. Nobody wants a camera in their bedroom. So that is one of the big reasons why, unless it's absolutely necessary, not a lot of people would go for it. Wearables are kind of iffy, particularly if you're wearing it throughout the night. Even if it's a ring, I mean, I've myself beta tested a smart ring for one of my other friends, and it doesn't really work out. I mean, it's a nightmare to wear those things. So then we basically looked at, like I said, we work on pressure sensors. So we basically started looking at what are the solutions in pressure sensing. There are some mats that are very small, like a pillow level mat that are out there and commercially available. But we thought we can probably scale it up. We can go mattress size and create a structure that is basically an entire bed structure that has something like a piezoresistive material, let's say a velostat thin film, can be used as a sensitive material, and we can have an electrode structure such that we can then look at what kind of loading is happening on the mattress. We tried to keep it as simple as possible. We could have gone with any number of sensor pixels here. Given the area that we have, and I mean, not a lot of crosstalk would be there anyway. But we only went with 8 vertical sensors for now to see what kind of effects we get. So we basically had a PVC sheet enclosure and encapsulation, particularly because, again, one of the practical issues that happens is you want the material to be waterproof, for bedwetting reasons. So that is definitely something that we had to cover, and we had to make it as thin as possible so that it can be placed on top of a mattress. So we made this kind of a structure, and it was flexible, of course, because the thickness is not a lot. and you can sort of roll it up and take it out and so on. There is some readout circuitry at the on the front that is basically used for converting these voltage and resistive readout into voltage and data. Now the key problem with this kind of a system is is that when you make a sensor strip that is that big, particularly if you're using a piezoresistive material. One of the problems with piezoresistive materials is that they don't have a linear IV characteristic because they are fundamentally based on tunneling as a principle of conduction, and because of that, what can end up happening is you get if you make a sensor strip that is this large and has a resistive material like this, you basically when you model it, it turns out that its resistance readout actually depends on where you're loading it, right? So the place that you're loading it from the output, for example, if you're taking an output here, let's say using a potential divider circuit like this, you have a constant VCC and ground connection here, and you have a fixed bias resistance here. So your analog voltage here is what you're basically looking at as a readout of the resistance. The problem is if you press here, the way the current distributes itself and goes out, the voltage levels that you get across the entire electrode structure dictates the amount of current that is basically going parallelly across the entire strip. And what that means is if you're basically pressing it here versus here, you get a slightly different resistive response. So that is one of the things that we had to look at and analyze that, and we sort of studied it and figured out that this is one of the reasons. I mean, and this is one of the things that needs to be taken care of when we have such a large sensor strip. Now, the nice thing about that was the resistance change is not that high compared to what we were trying to track, because we were trying to track whether somebody's sitting on it or sleeping on it or not. So the signal to noise ratio in our case was very large. So at least for the application that we were looking at, we were okay. But it was definitely one of the things that we figured out is a case, especially for very large, high aspect ratio sensor strips like this. Another thing, again, because of the same effect, what happens is that if you place weights in the same amount of force is applied more distributively compared to at a single point, you get the same effect of the currents that are going through distribute themselves in such a way that you get for a more distributed load, you get a lesser resistance as compared to a point load that is basically pressing at the center of the strip. Now, I mean, in this particular case, I'm designating these as 5 being one load that has been put. This is 0.5 kilograms, and at the center, and zeros are basically across the sensor strip. No weight has been put, and then if you distribute it like this, more further away from the center, you get slightly higher resistances. Again, these resistances, they look very different on a chart, but it's not a lot of variation compared to, for example, if you don't load it, you get of the order of tens of kilo ohms of resistance across the thin film. So the fall from there to this to 80 ohms and let's say 120 ohms is still a significant fall because of loading of the sensor. It's just that this slight variation is helpful as a characterization tool for later analysis of if somebody wants to do some other applications with these sensor strips. They can refer to this paper and figure it out. Anyway, so we were able to do this, and the best way of testing it is by actually sleeping on it. So you can basically get a grad student to do this. This is basically the response of the sensor when somebody is basically lying on it, and you can see that these are pressures that are so low resistance means high pressure. So as the person goes from one place to another, these 8 pressure sensors are basically telling you where the position of that person is and whether or not they're lying on the bed or not, which is exactly what we want to look at. So Again, if you characterize it a little more in a little more detail and look at the numbers, one of the things that we realized is again the signal to noise ratio that we are getting from these sensors is very large, and because of that, the loading effect and the distribution of weights and the positioning that I was just talking about in for this particular application doesn't really matter all that much. It at least tells you with just from looking at sensor values, you can basically figure out where that person is on the mattress or whether or not they're on the mattress or not. This is again this is actually the key result that we wanted to look at, because what this does, so this is time axis, time a downward y-axis. Starting here, we are having somebody on one side of the bed, no movement or nothing, and then at some point they decide to basically go on the other side of the bed, and at some point they basically go out of or walk away from the bed, and this can be then flagged as a potential fall event. The reason I'm saying it's potential fall event is because they can actually also walk away from the bed normally or fall, but in both cases, given that this is not going to be a very common occurrence, we can still flag this and ask the nursing come to at least check whether they're okay. In the future, what we're looking at is whether if somebody walks away from the bed and somebody falls, the signature of pressure that we are looking at, whether it can actually be different or not, and we can sort of then again classify it as such. One of the other interesting things that this kind of a system can do is if there's a no change in the position of a person for a very long time. Is one of the other things that again my friend told me. I didn't know about this, but there is a problem of bed sores that happens for elderly patients. So if they don't change their position in the bed for a very long time, they get bed sores on certain places where there's a lot of pressure being applied continuously. So if that is also, that can also actually be detected by this kind of a mattress. So if they are not changing their position for 2 or 3 or 4 hours, that can again be flagged, and then somebody can go and help them change their position and avoid bed sores as well. So this is again one of the things that we are an application that we actually came upon. So it's an interesting work. I mean, we again only proof of concept and everything else. We are not a company or an industry, but we are looking at ways in which we can sort of commercialize. A lot of data still needs to be collected, particularly for potential fall events, etc. A lot of data analysis is being done, characterization is being done. Even the number of sensors, where they should be positioned, all of those things are again under works. But it definitely is. It feels like an exciting start to a very interesting application. So that's all I have. Thank you very much for listening.